Hey guys, JD here. I'm doing a little project. Um, just a single axis horizontal solar tracking system. And I acquired just some 20-watt panels from Craigslist for free. So I'm going to combine these two parallel and double the inductive current to roughly 2.2. I think it's 1.19 per panel, so 2.2 on a sunny day where the panels are receiving a lot of photons and um, activating those photovoltaic cells, if I pronounced that right. It's okay if I didn't. And we're going to utilize an Arduino. I had harvested an R3 that they were using for a stepper motor project, and what a perfect candidate uh, to utilize in this project. And then I picked up a BTS 7960, a dual channel, actually no, it's a single channel PWM motor driver, and supposedly able to handle 43 amps, but my actuator is rated at 6 amps or less, and an 18 amp hour battery that I had laying around. It was on another little mini solar project, and so I just tested the actuator, and I ordered a Sky Shallow from Home Depot, and apparently they are, I guess, partnered or the same manufacturer as Vevor. So they sent me a Vevor actuator, and at first I really didn't want one because I had read some bad reviews about their IP65 actuators not actually being very waterproof. So I hope this works out good, and actuator seems to work fine, and I guess so. We'll see later though. Still working on a few things. Hey guys, just a simple demonstration of the single axis solar tracking system utilizing an Arduino microcontroller, motor driver, of course a linear actuator to drive the panel base and create a tilt. Also incorporating, of course, two photoresistors, which are placed on a platform with a single rise divider in the center to create a shading effect when the light, I'm facing pretty much south right now, so east of course would have the light at the moment, and my west side would be shaded. Thus the west photoresistor would have more resistance, and that would be read through the ADC of the micro 10-bit ADC of the more specific to this microcontroller, it's the Arduino R3, which is a 10-bit ADC, read out in 0 to 1023, and sending the 5 volts through to the photoresistor, and then reading that value back in the 10-bit resolution. Then we can incorporate some sort of logic into how the actuator should function, and I can show you that code later. But I just wanted to kind of touch on how these photoresistors work. They have a highly conductive material, cadmium sulfide, in them, and there's two bands, a valence band where the electrons kind of sit still, and then a conduction band. And when the photons from light hit the photoresistor, they excite the electrons enough if there's enough light, and they can jump the band gap from the valence band to the conduction band, allowing where and the conduction band is where they're free to move, the electrons, thus increasing conductivity and lowering resistance. And that's the basic principle of a photoresistor. And then when we send the 5 volts from an Arduino microcontroller into one side and then ground, well, preferably you'd want to add a resistor to help read the signal, and your analog input connection should be before the resistor, and then on the other leg of the resistor you want to go to ground. But let's take a look here on I have both of the photoresistors connected to multimeters. So let's take a look at the measured resistance measured in ohms from each photoresistor on the multimeters, and see how they vary. Presently, with the west photoresistor on this side of the shader, I'm reading 22 kilo ohms, and the east photoresistor is currently reading, well, I just shaded the light, about 41 kilo ohms. So that's the basic principle behind that. It's the light is shaded from one side or the other, will have lower or higher resistance. Now I have 17 kilo ohms on the east side and 27 kilo ohms on the west side. The west is getting slightly shaded now there, as my sun would be on the east roughly like 10 a.m. in the morning or so. I'm almost facing south right now. And I'll show you a little demonstration with the actuator here in a moment. So I'm going to be mounting my actuator upside down to try to minimize the amount of water intrusion into the seal here, so I can protect the cylinder and the motor assembly as much as possible. It is IP65 rated, but just to minimize that. And so the basic principle is, when my east side has more light, my actuator will extend the piston, thus pushing. This is a horizontal single axis tracker, so it's just going to tilt like this or this. It's real simple. So it'll push the piston out, which is mounted on the center post, which will then, of course, push the main base, or the bottom, or you could say the top of the actuator, into the tilting base that's mounted on the post, thus bringing the west into light. And this will be mounted on the solar panel base. And so I'm going to plug in the Arduino now and see if it's still functioning the way it was, or the way it's intended to. And we should see it extend now, because the east LDR has more light. And there it is, yeah. So it's going to extend till it finds a balance. And I'll tilt this now. and there it stopped because it found a balance between those readings. Hey, just an update here. Got the post in the ground, a makeshift battery holder, and a little electrical component box, and got the panels mounted on. They're just 220-watt panels mounted on the base, and the actuator is mounted as well. Still got to finish up the electrical, of course. Get those few devices or components in the box and everything wired up. Hey guys, yeah, I got the electronics put in, kind of crudely, but it's definitely functioning correctly. And just going to demonstrate a quick test. Currently, the analog reads are well within the tolerance, which I set to 20. If the difference is greater than the tolerance, then we'll have movement. Brain fart. So they're only like 11, the difference of 11 right now. And so I'm just going to simulate a light coverage on the east side, LDR, which will retract the actuator to simulate the sun or the earth spun more, thus putting the sun more to the west. So I'm doing that now, covering the east LDR. I'm facing south, and it's of course retracting, but the difference is not that prominent as it stands or as it stood previously, and that's fine. I don't want it jittering and going crazy. That's what the tolerance is for, and a delay. The delay is for. So I think it turned out pretty well. It's a nice little horizontal single axis tracking system, and the time lapse turned out really well there at the end. And I chose not to share the code because it's pretty simple code, and there's a lot of great examples on the internet and in the forums and the like. And I just wish all of you the best, and I want you guys to stay inspired, be weird, and be you. And we'll see you on the next one.